Right, so we're getting towards the business end of trigonometric identities now, proving them. It's not that bad. All you've got to do is look for an identity that you know already and use that to show it's true. So if we start with the right hand, before you can see you've got sine 2 theta since there, and we can say that if sine 2 theta is going to equal, we know, 2 sine theta cos theta, we can say that a half sine 2 theta is going to equal, or be identical to, sine theta cos theta. Now it might not look like we've got that close to the left hand side yet, but we have, if we say similarly, sine theta is going to be identical to, now 2 sine half the angle, and we can do the same thing as we've got over here, and then all we need to do is substitute that, since sine theta is identical to 2 sine theta over 2 cos theta over 2, we can say that sine theta cos theta is identical to 2 sine theta over 2 cos theta over 2 times cos theta, which is identical to, not the right, that's the left hand side, isn't it, as required. You might want to go back and look at that one more time, but it's all just using that same thing of sine 2 theta equals. All you have to do is keep on halving the angle and then substituting things in. So that's the first one. Now here's the second one. Write it down, have a go. You're going to be, as a little hint, you're going to be looking to change the left hand side, and you're going to be looking to use what you know about cos 2a for cos 4 theta. So pause it, have a go. But, so we're remembering that we're going to use cos 2a is identical to, and it's cos squared a, isn't it, minus sine squared a, and then we can say that that's going to be identical to, we want to get as many cos squareds in there as possible, don't we? So we're going to say that's identical to 2 cos squared a take 1, and that's because sine squared a is equal to 1 take cos squared a, so when we take 1 away we get the minus 1. When we take negative cos squared away we end up adding another 1 on. That's where that comes from. So we're going to use cos 2a is equal to that. We can say that the left hand side is identical to 1 plus 2 cos squared, halving this angle here from what it was to 2 theta, and then take 1. Well, 1 take 1 is nothing, so that's identical to 2 cos squared 2 theta, and that is the right hand side. So that's done. Just 2 more to go. Have a little look at this one, write it down, pause it, have a go. We're going to be using here the tan one, on the double identity, and that is, remember, you can work it out from your, get used to working it out from this one here. If you can't, so if those angles are the same, that gives you 2 tan A on the top, doesn't it? And that's all being divided by 1 plus tan squared A. So we're going to do that for this over here. I'm going to start with tan left hand side is identical to 2 tan theta over 1 plus tan squared theta. Oh, and I'm trying to get to this. Now, I wonder if you can see anything here. This is, if I could just divide that top by tan theta, that would be 2, wouldn't it? What's cot? Cot's 1 over tan theta. If I could divide that 1 by tan theta, I get to that. And if I divide tan squared theta, I get to that. At this point, notice I've got a plus instead of a minus, and that's because I've copied this down wrong, haven't I, for my identities? So that should be a 1, a minus. So I spot that mistake and correct that there. And then all we're going to do is divide top and bottom by the same thing, because that's an equivalent fraction, isn't it? And if I divide 2 tan theta by tan theta, I get 2. And then I've got 1 over tan theta minus tan squared theta over tan theta, and that is identical to 2 over, that's what we call cot theta minus anything squared divided by the root of it. Just gets us back to that root, doesn't it? Gives us that. And in fact, you could go straight from there to there. You wouldn't have to write that if you didn't want to. And that is identical to the right hand side as required. Happy with that? 1 more to go. So last up, pause it, write it down, have a little go. Right, so it might be puzzling you a little bit to work out which one to use here. If you look here, what we've actually got is an addition formula thing going on. Don't worry about the fact you've got that 2 there. This is just a cos A minus B, 2 different angles, remember. So we're going to go with that. So just to remind you what that is, cos A take B is going to be identical to cos A cos B, add this time sine A sine B, and that's nice because we want some sines to come into it, don't we? So we can say that the left hand side is going to be identical to, and we just need to double both these things because we've got this coefficient of the whole badger there. So we're going to have cos of the first angle times cos of the second angle plus 2 times again sine of the first angle sine of the second angle. We're trying to get to this. Oh, root 3, that sounds familiar, doesn't it? Oh, hang on. These are known values, aren't they? So it's time to get the old calculator out and rummage through and discover that cos pi over 6 is root 3 over 2. So we can say, oh, 2 cos 4 theta pi 3 over 2. And then here we're going to have 2 sine 4 theta sine pi over 6, make sure you're in radians of course, is a half. And that, 2 divided by 2 is, yeah, so that gives us root 3 cos 4 theta. And a half times 2 is 1, so that just gives us 1 sine 4 theta. And very happily, that is the right hand side as required. Dunsky, which means we can, I can't believe I just said that, never mind. So that's all the examples for today. Have a crack at some more. Exercise 7F, page 187, questions 1, 3, 4, 6, 7, 8, 9. I'll put a PDF on class charts for you there as well, and there's your answers, page 395. Okay, good luck with those folks. Let me know if you've got any problems.